Okay, so we have been talking about real numbers, rational numbers, irrational numbers, integers, and today the rewind was multiplication and division. Can somebody remind me the rules with multiplication and division of real and rational? Elijah? Good, a negative times a negative gives you a positive. What if there were 5 numbers and one of them were negative? What would your answer be? Negative. What if there were 4 and all of them were negative? Positive. How do you know that without even doing it? Okay, so what's like the shortcut way of doing it? Like how do you know if there's 12 numbers, all of them are negative, your answer would be, if there's 13 numbers, all of them are negative, your answer would be negative. Why? If there's 13 numbers and all of them are negative. If it's even, your answer ends up positive. If it's odd, your answer ends up negative. Okay, because for example, -5 times -5 times -5. What happens with these two? They cancel out, so that becomes positive 25 times -5. So your answer ends up being negative 125. And how many negative signs were there? 3. So if it's odd, the odd number of negative signs means your answer will be negative. An even number of negative signs means your answer will be positive. Okay, keep that in mind for today, because today what we're going to talk about is evaluating expressions that contain exponents and then applying the rules of exponents to algebraic expressions. All right, so what is this? What is this thing here? Jesse? An exponent. What does exponent mean? That number again. So in this case, how many times? 3. Am I doing 5 times 3? No. What am I doing? Good, which is going to end up giving me 125. Good. So it's that number repeated that many times. So which is the number that repeats, the 5 or the 3? The 5, and then the 3 tells you what? How many times it repeats. So this is called our base, and then this is called our exponent. All right, so what if it were a -5 to the 3rd power? How else could we write that? -5 times -5 times -5. And it's an odd number, which means my answer is going to be negative. So negative 125. If I did it again, now my answer would be what? Positive. Good. So 625 positive. Okay. What if I didn't have those parentheses here? What would be different if it looked like this? Say that louder.
You would do 5 times 5 times 5.
Okay.
If it wasn't in parentheses.
Okay.
Otherwise, you do 5 times 4. I think, right?
Not 5 times 4. Well, what do parentheses do? In math, what do parentheses do? Okay, they kind of tell you what to do first. Good. And they kind of hold stuff together, right? They keep things together. So in this case, what's actually being multiplied 3 times? All of this or just the 5? Just the 5. So this would be, the negative is not repeated. The only thing that's repeated is the 5. Okay, so if there's no parentheses, that means only the first one is negative. So no matter what, your answer will be negative, because there's how many negative signs? Just 1. Okay, so this is going to give me negative 125. All right, so that's kind of the tricky part. If there are no parentheses, there's only 1 negative sign, because that means that only the 5 is repeated, not the whole thing. So parentheses, again, they hold stuff together. So that means this whole thing is repeated 3 times, whereas down here, only the 5 is repeated, and the negative just kind of stays in front. And then since it stays in front, there's only 1 of them, so your answer ends up being negative always. okay? Your calculator will do that for you. Like when you guys start using calculators, if you don't put parentheses in, it will give you like a negative every time. Okay, so just be careful with that when you're using a calculator. If it's in parentheses, when you do it in a calculator, make sure you put it inside parentheses. What is this? What is this? One. Why is it 1? No matter how many times you multiply 1, what does it give you? 1 times 1 times 1 times 1 times 1 times 1, 35 times, it's still going to give you 1. For some reason, you guys will all tell me, like if when I said 5 to the third power, you guys all said that's not 15, right? You were like, no, that's not 15 because I have to do 5 3 times. But for some reason, when I make it a 1, people forget and they get thrown off, and then they multiply it and tell me it's 35. So just be careful with that one. That's a tricky one that people often make little mistakes on. 1 times 1 is 1 times 1 is 1 times 1. So no matter what, even if I do this, what's that? 1. Doesn't matter how big that number is, it's just 1. Okay, because I'm just repeating 1 a lot of times. Now if I asked you to write that out in expanded form, how long would that take you? A long time. I'm not going to ask you to do that. But if I did, you just write 1 that many times, right? So what's the difference between exponent form and expanded form? What is expanded form? Elijah? Yeah, just writing it out, right? Writing out what that means. Do you have to do that every time? No. If it helps you to be able to keep track of it, then maybe you want to. Because let's say you had something like this. 4 to the 4th power. What would that look like in expanded form? Okay, now if I want to actually simplify that, what would I do? 4 times 4 is 16. What's 16 times 4? 64. 64 times 4? 256. Or, that's right. Yeah. Or you could do, what's 4 times 4? And what's 4 times 4? So then you could do 16 times 16, which gives you 256. So sometimes that might be easier for you, like depending on how you want to do it. You can kind of group them together. All right, so with those odds and evens, remind me, if it's in parentheses, if the exponent is odd, your answer will be negative. If your exponent is even, your answer will be positive. Okay, so as long as you know your exponent rules, you should be fine with that. All right, let's try a couple. What's this one? 144. Why? 12 times 12 is 144. Is there another way of saying to the second power? What's another word for it? Squared. Very good. Squared is to the second power. Good. All right, what about this one? Is your answer going to be negative or positive? Positive. Why, Emmanuel? Because the exponent is even. Very good. So it's going to be positive. And then how many times am I doing 2 times 2? So I'm doing 2 times 2 times 2 times 2. What's 2 times 2? Times 2? Times 2. Okay. So before I start these, I figure out if my answer is going to be positive or negative before I start, and then I don't have to worry about it. All right. What's this one going to be? Positive 36. Good. What about down here? Positive or negative? Negative. All right. To the third power, what's another word for that? Cubed. Good. All right. So now I'm doing 2 times 2 times 2, which is what? Negative 8. And then last but not least, is this going to be negative or positive? Negative, because it's got an odd exponent. And I'm going to do 4 times 4 times 4, which is what? 64. So negative 64. Very good. All right. Are exponents hard? No. But why do people get them wrong all the time? Because they do. So why do you think people get them wrong all the time? Not necessarily because they're hard, but what? Parentheses throw people off a lot. Yeah. And then sometimes you just lose count. Like when you're trying to do a lot of multiplication in a row, you just lose count. So you will always see me write it out like this. I mean, I'm 31 years old and I'm still writing it out like this. Not because I couldn't keep track of it in my head, but because if I have an exponent of 5, I'm likely to lose count. Okay? So it doesn't take that long to write it out. That's my advice. Okay. So hang on one second. We're going to do this first. What if it has an exponent of 0? A battle for the ages. Is it 0 or 1? 1. It's 1. Anything to the 0 power equals 1. Why? Does anyone know why? David, what do you think? Mm-hmm. Mm-hmm. That would make you think it'd be 8, right? So that would be, if it were 8 to the 1, then that would equal what? 8. Does anyone know why this is 1 though? Okay, I'm going to show you. All right, let's say we have this. Just go with me down this rabbit hole that I'm taking you down. All right, how do I write this in expanded notation? All right, how do I write this in expanded notation? What changed from here to here? 1 less 5, right? How do you get rid of a multiplied by 5? Because that's what I want to get rid of. I want to get rid of a times 5. How do I get rid of a times 5? How do you get rid of multiplication? What's the opposite? Division. So if I want to go from here to here, I would do what with this? Divide it by 5. Because if I divide this by 5, what happens to 5 over 5? Yeah, it goes away, right? So now if I want to get rid of one of these, what would I do? Same thing. What happens to this one? And what do I have left? Which is the same as 5 to the... Okay, keep going down this rabbit hole with me. What happens now? Cancels out. What do I have left? And that's 5 to the what power? 1. Okay, now what happens here? 5 over 5 is equal to... That's why anything to the 0 power is 1. Because essentially what exponents are doing is as your exponent gets smaller, you're dividing by that number, and anything divided by itself is what? 1. So that's why anything to the 0 power is 1. So 1,000,000 to the 0 power equals 1. 10 to the 0 power equals 1. Literally anything to the 0 power is going to be 1, and that's because something divided by itself is 1. Okay. All right, go do these 15. Careful with your signs.